stunning concept images have revealed a glimpse of what homes of the future could look like, as preparations are made for the world's first freeform 3D printed property. Experts will build a house called Curve Appeal, whose structure will be made from 28 panels, which will be 3D printed off-site before being slotted together on-site to create 2 exterior walls, a roof and interior core. These 4 main sections will then be hoisted into place and joined together, and will feature a complex blend of curved angles and glazed windows. Although 3D printed buildings have been made before, this futuristic home, to be constructed in Chattanooga, Tennessee, later this year, will be the first of its kind, as it will contain no regular shapes or angles. Scroll down for video. The house is the creation of design company WATG, based in London and California. The design for Curve Appeal draws inspiration from the case study house program, developed between 1945 and 1966. The program oversaw the design of 36 highly experimental prototype residences that could be constructed easily and efficiently, reinventing the modern home. The architects leading the program were famed for constantly pushing the limits in terms of minimalist materials, and striving to create open-plan spaces that focused on enhancing natural light. In a written statement, a spokesman for WATG said, employing many of the same modernist design principles, Curve Appeal is the next evolutionary step, blurring the line between inside and out. It's important that the architecture and the environment work together harmoniously. The chosen site is steps away from the Tennessee River in a beautiful wooded, sunlit area. This allows the house to blend seamlessly into the environment, while also being naturally shaded and protected from solar radiation. WATG is currently producing detailed design drawings and working in collaboration with the City of Chattanooga to ensure the project is advancing according to the intended timeline. WATG was awarded first prize in the Freeform Home Design Challenge in 2016 and given prize money of $8,000, £5,700, to make its plans a reality. The competition, launched by Branch Technology, an architectural fabricator specializing in large-scale 3D printing, was aimed at architects, designers, engineers and artists. Participants were challenged to design a 600 to 800 square foot, 56 to 74 square meter, single-family home that rethinks traditional aesthetics, ergonomics, construction, building systems and structure. The freeform stipulation meant that the buildings were not to be of regular or formal shape. Over the last year, WATG's Chicago office has been developing their design with Branch Technology. Wall section testing, research, and development phase of this revolutionary project is currently underway, working towards breaking ground later this year. Once complete, the Curve Appeal home will have open and light-filled interior living spaces. Passive strategies will be employed for keeping the building temperate, such as carefully located windows that can create air through draft and features that can help foster warmth in the winter and keep the building cool in the summer. It is hoped that the large expanses of glass will help to connect the occupants to the outside and to nature. Using Branch Technology's freeform printing process, complex design forms are no longer difficult or expensive to build. Within the home, the complex shell geometry is not only aesthetically attractive but structurally functional. The arching form provides structural rigidity to the residence, using various spring points throughout the floor plan, allowing the structure to carry roof loads and provide large open-plan living spaces, shaping structures in new ways without any restrictions. Enlisting the services of Thornton Tomasetti, the team has been printing test beams and partial wall sections to examine their load-bearing capabilities. In generic printed beam tests, a 3-foot-long beam could carry a load of approximately 3,600 pounds, 1,360 kilograms, while only weighing 5 pounds, 2.3 kilograms. The freeform printed matrix is essentially a small space frame, making it highly efficient. The next stage will be to test the maximum load-bearing qualities of each individual printed element of the structure. Working alongside United States Gypsum, WATG and Branch Technology have been researching a variety of gypsum material components that could be applied on the printed structure to work as fire protection, structural reinforcement, and to create a substrate for the application of finished wall materials. WATG and Branch Technology have engaged Interface, a high-performance mechanical, electrical and plumbing design firm, to design a passive mechanical system with the aim of making the house net zero energy. That result of which is that the house will produce as much energy as it consumes, reducing its carbon footprint.